Hi everybody, this is Mrs. Michek. Today we're going to be talking about how to calculate heat, and specifically either the amount of heat given off by an object or the amount of heat absorbed by an object when its temperature is changing. So before we get into that, I wanted to show you what is called a cooling curve or a heating curve. So on the left we have a cooling curve and on the right we have a heating curve. So the reason that I'm showing you these is because yesterday in your notes you should have found the formula Q is equal to MC delta T. And this is the formula that we're going to be working with today, but this formula directly applies to cooling curves and heating curves. The way that it applies is because on these heating curves and cooling curves, you are actually calculating Q. Not at all of the locations though. So for example, if I asked you to calculate the amount of heat given off by an object as it cools from, or given off by water as it cools from 0 degrees Celsius to negative 12 degrees Celsius, you would be calculating the amount of heat given off by water right here. So notice that's on our cooling curve. Okay, notice that I gave you 2 points of water below freezing. Okay, water when it's below freezing, it's in the solid phase. Okay, so that's where our delta T comes in. Notice on the cooling curve and the heating curve, our temperature is on the left. Okay, our temperature is changing. So, that's where this applies. So, on all of these slanted lines, you can calculate Q. So, you'll notice that I put a solid on the bottom of the cooling curve. That means this middle one would be our liquid, and the top one would be the gas. Okay, on the heating curve, it's going to be basically the same, only kind of flipped around. The bottom one is still the solid, the middle one is still the liquid, and gas would be the top one. So you might be wondering, well, what's calculated at these straight lines? And we're not going to get into that so much today. We will get into that next week. That is something called delta H. Okay. So delta H is what is calculated on those straight lines. And delta H is how we calculate the heat absorbed or heat released as, or while an object is at a phase change. So as we go from a solid to a liquid, that's melting. Okay, as we go from a liquid to a gas, our object is vaporizing. Okay, if we go back to our cooling curve, a liquid to a solid is freezing. Okay, and we would still be calculating delta H. As we go from a gas to a liquid, that is condensation. Think of your water when you go outside and the water starts to condense on the outside of the cup. That's called condensation. So if we're calculating the heat of condensation or freezing, melting, or vaporization, each one of those is going to be done using delta H. And again, that's going to be next week. Today we're concentrating on this formula, Q equals MC delta T. So to get into that, I want to talk about what Q equals MC delta T means and what it stands for. So throughout the year, I have talked about, I'm going to start on this end, the delta T. I've talked about, or I've used delta sometimes in class, and I've been like, delta da 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 da. Okay, delta means change. So this is our change in, I put a T for temperature. Well, the way we calculate the change in temperature is taking the final temperature that we're given and subtracting the initial temperature. So that's going to be our change in temperature, or delta T. C is the specific heat. Specific heat is going to be a constant, but a constant for every different substance. So water is going to have a specific heat, and that will be a different specific heat for every phase. So water as a solid has a specific heat. Water as a liquid has a specific heat. Water as a gas has a specific heat. Usually we're using liquid water as 4.18 joules per gram degrees Celsius. The units that you're using are joules per gram degrees Celsius, or you can use calories per gram degrees Celsius. To go back for just a hot second, change in temperature will be degrees Celsius. The reason we're using degrees Celsius and not Kelvin is because of our specific heat being in either joules per gram degrees Celsius or calories per gram degrees Celsius. We're going to need all of our variables to cancel. M in this case is for mass, and our mass is going to be in grams. Notice it's in grams, not kilograms. So if you're either given kilograms or asked for kilograms, you will need to convert. Q is our heat. So if you're asked for the amount of heat, you are being asked for Q. And heat is measured in calories. Notice that's a little c. That's not a big C. So that's not kilocalories. And joules, or joules, I should say. And again, notice that's not kilojoules. All right. We're going to do a couple practice problems. First one, pretty easy. How much heat is required to warm 122 grams of water by 23 degrees Celsius? The specific heat of water is, and this is liquid water, by the specific heat of water is 4.18 joules per gram degrees Celsius. All right. Using our formula, Q is equal to MC delta T. I'm going to go through and underline what I know, so I'm not taking up a whole lot of room on here. Okay, I've got 122 grams. That's my mass. When it says that it's going to warm my water by 23 degrees Celsius, that's going to be my delta T. Okay, so sometimes it'll give you both a final temperature and an initial temperature, and you'll have to subtract to find delta T. In this case, it says it's warming the water by this much, so this is giving you delta T. The specific heat of water is 4.18. Okay, so this is my C. It's asking how much heat, and again, heat is Q. So we're trying to find Q. Our formula is already set up for Q equals MC delta T, so I can plug everything in just as it is. M is 122 grams multiplied by my C, 4.18 joules per gram degrees Celsius, multiplied by my delta T, 23 degrees Celsius. I do want to make sure everything cancels. Remember, Q should be in a unit of energy, which is calories or joules. So I want to make sure that everything cancels to the point that I will be left with either joules or calories. So I don't want to be left with grams, so I want to make sure that grams cancel, and I have grams on the bottom. Notice it's joules divided by grams, so that cancels. Celsius is on the top. Celsius cancels with Celsius, which is on the bottom, joules divided by Celsius. And joules want to make sure there's no other joules that it'll cancel with. I'm good. All right. So I'm going to get out my calculator. And I get oops. $11,729. If we want to round and put that in scientific notation, we could write Q is equal to 1.17 times 10 to the 4th. And I got that by 1, 2, 3, 4 spaces. Joules. Okay. One more problem. This one's going to be slightly more difficult. If you felt pretty solid on this one, you can look at the next one. Do it on your own and check the answer. Okay. This one says, what is the mass? So we're not looking for heat in this one. What is the mass of a block of granite that loses 3.9 times 10 to the 6th joules as it cools? And that should say joules of heat or joules of energy. As it cools from 60 degrees Celsius to 13 degrees Celsius. And then it tells us the specific heat of granite is 0.803 joules per gram degree Celsius. So this is going to take me a little bit more room. I'm going to set up our formula on this first whiteboard. We've got Q equals MC delta T. I'm solving for mass. So if I want to get mass by itself, the way that I can do that is by dividing both sides by C delta T. So my formula now is going to be, I'll rewrite it down below actually. I'm going to be able to see that. M is equal to Q over C delta T. Okay. Now I want to go through and underline everything that I have. All right. So I've got 3.9 times 10 to the 6 joules. That's my Q. As it cools from 60 degrees Celsius to 13 degrees Celsius, I can use that to calculate my delta T. And I'll have to do that on a separate whiteboard. Or actually, I can do that right here. Delta T. If we remember, delta T is equal to T final minus T initial. Alright, so it says that it cools from 60 degrees Celsius to 13 degrees Celsius. So I'm going to do 13 minus 60. Alright, so my delta T is going to be negative 47. Okay. And my specific heat of granite is 0.803 joules per gram degree Celsius. Okay. So I have everything to plug into my formula. One thing that I want to point out, it says the granite is losing this much heat. If it's losing heat, I can change this to a negative value to imply that it's losing the heat. All right. So make sure you have all of this written down. so that we can plug in to this formula. All right. So we've got our formula. Q equals, not Q equals, M equals Q divided by C delta T. And then we can just plug in what we underlined. M is equal to, and our Q was, remember, negative 3.9 times 10 to the 4th joules, divided by C was 0.803 joules per gram degrees Celsius, multiplied by our delta T was negative 47 degrees Celsius. Okay. Plug this into your calculator, and again, I would make sure, just like we always do, to put parentheses around the bottom so that you are dividing this value by this whole value. All right, and I get the mass to be 1,033.36. And we didn't go through and cancel our units, so we can do that quickly. Make sure our units are correct. Make sure we have a unit of mass. Joules cancels with joules on top right there. Degrees Celsius cancels with degrees Celsius. Remember that grams on the very bottom, the bottom of the bottom, 1 divided by 1 divided by grams is going to equal grams. Okay. So our mass is 1,033.36 grams. And that's it for how to measure heat. I hope that you've enjoyed.